Hello and welcome to the Daily Space for today, March 21st, 2019. Today we have more news of the rocky sort and a little bit of high energy science just to get things, excited at the beginning of the show. As always, as often happens, I am your host, Dr. Pamela Gay, and I am here to put science in your brains. We are your daily place to learn all that is new in space and astronomy. And if you miss a live episode, click on over to YouTube and you can catch all our content there. And if you could please give us a sub on YouTube, it would greatly help our channel. So in today's top story, we have a case of supermassive black holes gone wild. It has long been known that there are bubbles of gamma ray emitting high energy particles above and below the plane of our galaxy, directly in line with the supermassive black hole that lurks in the center. Now, using the XMM Newton Space Telescope, astronomers have been able to map out this central region, and as they've found, shown in yellow, this southern and northern chimney, shown in yellow, that extend up and down towards a red gamma ray in the top and red, still learning this whole green screening thing, and down towards this green bubble of gamma rays in the bottom. These connecting chimneys allow us to finally and definitively say that it is material coming from the surroundings of that black hole that has generated these gamma ray bubbles. And it's these X-rays in what are termed chimneys that are the definitive markers. And thank you, Mythtown. So, the way this works is when material is streaming in, and can we light up the chat for that, please? When material is streaming in towards the supermassive black hole in the center of our galaxy, the material spirals around, forming what's called an accretion disk, a high energy disk of material that, because it's excited, sheds some of its electrons, making the particles charged. Charged particles generate a magnetic field, and that magnetic field is able to scoop up and send at high velocities some of the particles in this system. Those high energy particles, as they hit things surrounding that central supermassive black hole, give off different colors of light. X-rays are a slightly lower energy emission. The gamma rays are a much higher emission that occurs when all those particles barrel in to the medium above and below that supermassive black hole. So now we have a picture of our supermassive black hole chowing down on some of the substance of our Milky Way galaxy and burping out, high energy particles through the accretion disk. Nothing comes out of the black hole. I just want to state that again. Nothing comes out of the black hole. This is all material that would have gone into the black hole, except it got jettisoned by the magnetic field instead. That magnetic field jettisons these particles. Now, we're not exactly sure when it was that our supermassive black hole did this eating that generated what we're seeing with this chimney and these two bubbles. But it's nice to have a little bit more observational evidence that the theories we had for where the gamma ray bubbles came from are proving out as we look in other colors of light. Now, that's the high energy bit of today. From here on out, it's all about those rocks. This is a wild and awesome week for planetary science. Right now in the woodlands outside of Houston, Texas, there is the Lunar and Planetary Sciences Science Conference taking place. This particular event brings together more than 1,000 planetary scientists from all over the world to discuss what they are learning with all the spacecraft we have orbiting and on various worlds in our solar system. This particular picture is one of the newly released images from the OSIRIS-REx mission that is orbiting the asteroid Bennu. Now, Bennu is turning out to be way more rocky and rubble covered than we ever imagined. One of the things that really struck me is if you go back and you look at any of the mission animations that were created prior to the encounter, they show Bennu as a world with a lot of rocks, but also some fairly clear areas. And it was in those clear areas that they were planning to go in and grab a rock and bring it away with their best described as an angry vacuum tube. They have a cone that goes down and it has these grinders on the edge of the cone, and these grinders, just like the brushes in your vacuum cleaner, push the material up into the cone. And this angry vacuum cleaner is supposed to bring material back to the planet Earth. We just have to find someplace safe to dive in and grab some rocks. And this is going to be a challenge. And as one of the people who's helping accomplish that challenge, I have to admit I am now intimidated by an asteroid. It is possible to be intimidated by inanimate objects. I knew this from Thanksgiving dinner. Now I know it about rocks as well. So, it's a really, really rocky world. And this is not all. This wild world has so many other things to surprise us with. It is a rapidly rotating world. And the reason that it is rapidly rotating the way that it is variations in how sunlight hits it are causing this world to speed up in its rotation rate at a rate of about 1 second per century. This means that over time, it is very, very slowly speeding up in its rotation. Now, 1 second a century doesn't sound all that exciting, but over the millions and millions of years that this rock has been hanging around, covered in rocks, that's a lot of speeding up. So it's a rapidly rotating object, and it's also an object that we now know is active. There are, for reasons that are still being figured out, jets of material coming off this asteroid. Now, there was a fabulous comic yesterday that I saw, there was a fabulous pseudo discussion that I saw yesterday. These things are coming from Andy Rifkin and Alex Parker, if you follow them on Twitter, from the LPFC conference, where there was theoretically a conversation between Bennu and Ryugu, where Ryugu was like, "Oh my God, I just got shot with a bullet." The wording was different. And Bennu was like, "Oh dear, stand by." And then it ends with this image of like Bennu firing material up toward the spacecraft in orbit, theoretically defending itself from that angry vacuum cleaner. Now, that isn't actually what's going on. And one of the possible scenarios to explain what is going on is that there are what are called volatiles, materials that exist in a frozen state until exposed to sunlight, that when exposed to sunlight suddenly transition, sublimate is the word, from a solid to a gas. And the rapid expansion of the material as it goes through this phase transition causes material to get strewn off into space. Now, this is not something that any of us were expecting. It's really kind of awesome. And we have so much to learn from this world. And it's just going to get better with time. This particular image was taken with OSIRIS-REx 1 mile above the surface of this world. So it's not just Bennu, though. Ryugu is also continuing to reveal its secrets. As the team behind Hayabusa 2 continues to study the data that they are getting from their own orbit of their own small rock, they are finding that this particular rock chemically appears to have come off of one of 2 other asteroids. And what I love about this is our image of the origin of asteroids is basically oscillating in on the truth over our lifetimes. As a small child, I remember learning falsely that the asteroid belt was a planet that had been shattered. Well, there's not enough material in the asteroid belt for it to have ever been a planet. And so that understanding got replaced with the idea that asteroids are leftover bits of our early solar system, which is still true. And these leftover bits are so greatly spaced apart that collisions probably never happen. That's the false part. We are now learning more and more detailed exactly how these different objects got hit and how they then sent their fragments of debris towards us and towards the inner solar system. Yesterday, we had a story about how a meteorite strike in Turkey was traced back to a specific crater formed on Vesta a few million years ago, a few tens of millions of years ago. Well, today we have a press release involving Ryugu, where they are blaming one of two asteroids, they're not sure which yet, on the formation of this object. So the way they phrase this in their press release is Ryugu's chemistry suggests that its parent asteroid had some water in its rocks early on, but lost most of that water before the breakup that led to Ryugu. Pinning down the timing of Ryugu's water history could help scientists understand how much water may have been delivered to Earth by asteroids in the early solar system. And that parent asteroid is probably Polina, or, and I'm going to pronounce this wrong, I think, Juliana. Or Juliana, I'm not sure. So we're getting more and more understanding. And this understanding of which of the two asteroids it came from was already hinted at. We had already known it probably came from one of these two objects long enough ago that the OSIRIS-REx team created this infographic, which compares these two rocks. They're very similar in size, 500 meters across, 900 meters across. As an astronomer, anything that has the same number of zeros is close in size. You can see that they're both what are called near-Earth asteroids, asteroids that have orbits close to the close to the orbit of the Earth, and both of them actually have orbits that cross the Earth's orbit, making them potentially hazardous asteroids. They were both discovered in 1999 by the Linear Survey. This is a survey that was looking for things rather, that could potentially take out the planet Earth. It's always to know what just might be on the attack. They are both blamed on Polina and Juliana. This is a particular family of asteroids that are designated by their dark color and other chemical signatures. And what's kind of cool is both of them have retrograde rotation. That's part of what indicates that they probably had some sort of a dramatic and violent background. Now, they do have differences between them. They have different orbital periods, they have different rotation periods, they have slightly different orbits, and they're actually slightly different compositionally, where the one has more metals than the other. So we're slowly learning more and more about these two objects, but they're related. They came from a violent point in the past of our solar system when asteroids were a lot bigger and fewer in numbers. And now we have spacecraft out there attacking them with bullets and angry vacuum cleaners. And they're getting ready to bring back samples to Earth so that we can go beyond studying these things in reflected starlight to instead studying them, well, with a mass spectroscopy setup, taking them apart, imaging them in detail to understand exactly what their history is. So this is our science for today. Now, before I move on to taking your questions, I do want to say we have opportunities for you to go out and join us in the real world looking up at the stars. You can join me and many of the other faces that you may know from right here on Twitch. Join me, Skylius, Fraser Kane, Paul Matt Sutter, John Michael Gautier, all out at Joshua Tree Park in June. The link for that is astrotours.co/all-starstrider. Now, if going to Joshua Tree in June isn't for you, that's okay. We have other opportunities. If you would instead like to tour through the American Southwest with me, you can do that too. Starting in the end of August, we will be departing from Tucson, Arizona, and then traveling through the desert, going to astronomical facilities, going to amazing sites of geology and nature, and ending in Las Vegas. Now, we are looking to find events that are free to do things in addition to this, but these are chances for you to take your vacation with me. And I hope some of you will. I'd love to meet you in person. So that concludes the slides I had prepared for today. So go ahead and type all your questions in. And while you're doing that, I'm going to remind all of you that the Daily Space comes to you most Mondays through Fridays right here on CosmoQuest X on twitch.tv. If you miss us live, catch us over on YouTube. And if you can, give us a subscription. They really help our channel. And this isn't all we do. We also have the Sunday Science Hour. We have live coverage of launches, landings, and other special events as they happen. And we're able to do all of this thanks to the generous contributions of people like you. Now, I often kind of feel a bit like I'm going to drive you all away because I'm sitting here begging for money. And this morning when I woke up, I turned on my local NPR station because I'm that kind of a person. I'm an NPR listener. And as I listened to them doing their pledge week, I was like, oh my gosh, I'm going to turn this off and listen to some podcasts. But while I turned them off, I also made sure that my monthly pledge to NPR is still going through. And I'm hoping that if you like this content, you will do, well, the kinds of things that NPR asks you to do. You'll consider donating, well, the price of a cup of coffee each month, a subscription, a Patreon follow, to keep our content going. When you do this, what you're paying for is bits of my salary, all of Annie's salary. You are paying for us to maintain our servers. You're paying for some of the site licenses we need. Thank you, Mecha Grumpy, for the follow. Basically, you are keeping the science going. And with CosmoQuest, we are your place to learn and do science. And after this show is over, I'm going to be getting, well, my coding hat on, and I'm going to be working with Tanner and Tim. You may know Tanner as Herleu, to work on finalizing some finishing touches on getting our site back up and running. We are here to help you do science, and we will be inviting you to please, for the love of God, help us map out Bennu in just a few months. So thank you all for being here, and I am going to take your questions, and I'm so grateful that you let us be here through your donations. Thank you. Okay, so now to scroll through the chat and see, and remember to @ me, and see what all you have asked. Good morning, all of you. I'm seeing the good mornings in there. So Larry Weird and Proud is asking, did I hear Fraser right yesterday? It's Bennu, so light in density it could float. I don't know. Fraser usually checks himself, so if Fraser said that, I would go ahead and believe that. So Larry Weird and Proud asks, which has more metals, Bennu or Ryugu? I think it's Ryugu. Let me fact check myself. Wow, can't spell Ryugu. I can't fact check this quickly in real time. If memory serves, Ryugu is a more metallic, it's more nickel rich than Hayabusa. Not Hayabusa. It's more metal rich. It's a spacecraft. If memory serves, Ryugu is slightly more metal rich than Bennu, but that's from memory, which means please fact check me. Okay, scrolling. Henny's Warverb asks, what would be the effect on a galaxy that was hit by another galaxy's jet? Would it start or hinder star formation? It depends on how the jet hits. it could indeed, if two galaxies were quite close to each other, it could indeed create the kinds of shocks that do cause the collapse of giant molecular clouds and lead, well, potentially not just to star formation, but if it hits a large intergalactic cloud of gas and dust, one of these massive giant molecular clouds that exist between the galaxies, creating what we call the Lyman alpha forest, it could potentially trigger a small galaxy formation, which is super cool to think about. So D7V1D asks, could the samples be toxic? Yes. We keep them highly, highly sterile, highly, highly isolated from human beings. They're in a vacuum setup. The Japanese have done excellent work. Now, we're not so much worried about they're contaminating us. I wouldn't eat them. Most metal is toxic. So that is why I so enthusiastically say, yes, it's probably toxic. So is dirt. Don't eat it. Well, not all dirt. Children should get dirt in their mouths. It increases their immune system, but that's for a different show. Our bigger concern is us contaminating those samples and making it harder to do science. So don't eat asteroid samples. They will do bad things, maybe, to your digestion. All metals in large amounts are toxic. But we're much more worried about us contaminating them. So Archie Haddock asks, a meteor caused a huge explosion over the Bering Sea in December. What would happen if it hit the surface of the Earth? What is needed for them not to explode before hitting the Earth? Is it just the size? So it actually has more to do with the composition, whether or not an incoming object is going to explode in the atmosphere or hit the surface of the planet. The things that make it to the surface intact tend to have a higher metal content. They tend to basically just be bonded together that much stronger. If you take a rubble pile, so imagine grabbing some really tightly bound rocks and patching them together with mud. Well, if you take that and you throw it, it's probably going to fall apart in the air. But if instead you just throw a rock, it's going to hold together in the air. Well, if you have an object like an asteroid that isn't highly bound together, or even worse, has a lot of ices in it that are going to radically expand, it's going to blow apart in the atmosphere. Now, this can be good. So things like what you saw don't hit the surface, and an object hitting water is actually kind of worst case because it can cause a tsunami. So blowing up is good. Now, most of the objects that we see creating these fireballs are at most a meter or two across. So they're going to cause smaller craters when they hit. They might ruin somebody's house, but they're not going to ruin somebody's city. The city killers, the planet killers, these we're working really hard to detect ahead of time. If we detect them far enough ahead of time, we have the capacity to move them. It just takes a will and money to build the spacecraft to go and move them. So this is what we worry about. We have a lot of different surveys out there trying to detect things before they'll hit the Earth. And we're actually getting to the point that we're starting to see things days ahead of time for even the smallest things that are going to come in and burn up over the atmosphere. And this can be useful for telling airplanes, maybe be on the watch. There was a case a few years ago of people in an airplane actually being able to observe a object burning up in the atmosphere. And that was kind of cool. Okay, so let's see what else. Henny's Vorwerp is asking, will the return samples be gravel-sized or dust? We don't know. It depends in part on luck. With Hayabusa, at least, they have the capacity to pick up objects that are as big as 1 centimeter across, but they're assuming that they're probably going to get stuff that is more pea-sized and much smaller just because they're trying to dislodge things with a bullet. Now, with OSIRIS-REx, they're grinding things up with these treads that they're rotating on the surface. And again, we're just gonna have to wait and see. Thank you so much, Aaron73. Thank you. Can we light up the chat for that sub? Thank you. Let me transition over so you can see the dogs eating the bits. So thank you. Now, what else do we have in the chat? So Checker Kev asks, does the solar effect always spin up and not spin down bodies? I think it depends on how they're shaded. I mean, it should be able to do both. It just depends on how they're shaded, how they're rotating. The way to think of it is angular momentum is causing our own Earth's moon to slowly move further and further away from the Earth as the Earth becomes more tidally locked to the moon and our planetary rotation slows down. This is because the Earth's orbit around the Earth is slower than the length of its day. Now, with the moons of Mars, its inner moon is actually becoming more and more inner, you might say. It's slowly migrating toward the surface, and it will eventually get shredded by the gravity field of Mars. And this is because its orbital period is less than the Martian day. So there's lots of different things to take into consideration. So Henny's Vorverp is asking, would we need a polar orbiter to see all these meteors coming? No, it's more a matter of just having more. So by putting survey systems in the northern or southern hemisphere, as long as they're not exactly on the equator, you can get a view of the pole. The issue is surveying the entire sky, because the sky is awful big. So most of the surveys that we have are picking and choosing what areas of the sky that they're seeing, or they're only seeing things that are particularly bright and thus particularly potentially destructive. So we mentioned a few weeks ago the new Fritz Wiki transient facility out in California. And it is capable of seeing the entire sky as visible from its location on the Palomar telescope. Now, that means that it misses everything in the southern hemisphere, and it is limited to only being able to see things of a certain brightness. In the end, we're all kind of waiting for the Large Synoptic Survey Telescope to come along and wishing that it had a twin in the northern hemisphere. Because it's really going to be the big scope out there surveying down to the greatest depths and detecting the largest number of these things. It's estimated that there will be tens of thousands of things that go flicker, flash, and move through the night, each and every night for that telescope. Scrolling, and I think I got everybody's questions. So, do you have more questions? Hello, Bill Nash. Can we get a shout out for Bill Nash? He is another streamer here on Twitch. He streams quite often in the evenings. He does a lot of photography, and it's just like a pleasing stream to watch, filled with beautiful things that periodically includes astro images. Good morning. Bill Nash asks, given the wide field of view of tools like TESS, is there a side use for that data in detecting asteroids? I don't know TESS's data pipeline. So the issue is that stars and asteroids move through the field of view of telescopes at different paces. So you want to use one kind of tracking rate across the sky to detect stars very, very precisely. And that means that asteroids moving through that field are going to be streaks. And if you have a data pipeline that specifically looks to see what are all the point-like objects in this field, and throws out the data from everything that isn't point-like, then you don't get to detect the asteroids in the field. And I don't know if the automated data routines that they use on board tests are keeping asteroid data or throwing it out and not sending it back to Earth. I simply don't know. I know that Kepler would have thrown that data out and not been able to see asteroids moving through its field. So yeah, it all depends on how it works. Hello, fellow hoodlum. It is super late in your day. Hello, Lady Pembroke. So D7V1D is asking, how do we move them, referring to asteroids? So the way this works, and here I am looking for my pseudo-asteroid. I have a meteor. There. Meteorite. So here's our chunk of meteorite. Now, if I want to move this chunk of meteorite, what I want to do is take a spacecraft, in this case my Apple AirPod, and place it in front of the asteroid. This is so not to scale, people, so totally not to scale. Place my spacecraft in front of my asteroid and fire its engines so that they are going above and beyond, above and below the asteroid, and slowly move my spacecraft so that its gravity has the capacity to move ever so slightly the asteroid in a new direction. So one way to do it, it's called a gravity tug, and you just put a spacecraft near your asteroid, but in a way that pulls it in a new direction with gravity. Now the other way to do it, which I'm not going to do to my meteorite because I like my meteorite. Thank you so much, Lady Pembroke. There you go. Go over there. So can we light up the chat? So the other way to do it is you take your meteorite and you paint part of it white. And when you do that, it turns out the sunlight and the transfer of momentum when that light hits the meteorite has the capacity to move, well, not the meteorite in this case, but an entire asteroid. I just love the idea that we may someday be covering an asteroid in brightly colored graffiti in order to save the planet Earth. So, Banksy on an asteroid, people. This could be a thing. Yeah, it is super cool. D7V1D. So do we have any other questions? Bill Nash, that definitely needs to happen. Definitely needs to happen, to occur. Okay. Sci-fi musical, Paint Your Asteroid. I could get behind that, Zizink. I could definitely get behind that. All right, so if we don't have any more questions for today, I'm going to go fill my head with more science, fill my computers with more code, and work to make the world a bit more scientific for all of you. Now, your learning can continue right here on Twitch. I am going to raid over to, oh bother, I think. He's working on a 3D printer enclosure. So lots of engineering coming your way in just a moment. Now, just as a final reminder, we bring you the Daily Space most Mondays through Fridays at 1 p.m. Eastern. That is 10 a.m. Pacific. Right now it's 5 p.m. London time, but that will change when you change to daylight savings time. Apologies that the entire world has its own way of deciding exactly what it wants the time zones to be. So check it all out and give us a follow to find out whenever we go live. We are here not just for the Daily Space, not just for the same time, same place, Sunday Science Hour, but we also work to bring you launches, landings, and other spacey special events as they happen. We are part of the Planetary Science Institute, a 501c3 dedicated to exploring our solar system. Check it out at psi.edu, and your donations are tax deductible wherever tax laws allow. Thank you for your support. Thank you for being here. And thank you, spam blocker, for only letting that ring once. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And if the weather allows, go outside and look up. Bye-bye.